Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 19, 2025, about 5 days ago. It shows that a compact agentic vision system for geolocalization can greatly outperform other open-source agents and reach performance comparable to models like Gemini 2.5 Flash and GPT-5 on most metrics. The paper is titled GeoVista, Web-Augmented Agentic Visual Reasoning for Geolocalization, and as we will see later, the combination of web tools and visual reasoning has really interesting implications for future multimodal agents. Also, the authors shared an official GitHub repo for GeoVista. Inside, you will find installation scripts, environment setup, and example commands to run the geolocalization model with VLLM. The repo includes inference and evaluation pipelines for GeoBench, scripts to download models and datasets, plus example multimodal queries and nuanced evaluation tools. Figure 1 illustrates how the GeoVista agent actually thinks through a geolocalization problem. The left panel shows the model starting from a street photo, zooming into road signs and murals, then calling web search to confirm that these clues indicate a specific tunnel and city. The right panel presents a panorama case where the agent zooms into rental advertisements, extracts German text, and uses web results to narrow the answer to Berlin. Together, these examples demonstrate a tight loop of visual zooming, textual reasoning, and web evidence checking. Figure 2 illustrates what GeoBench images look like and how the GeoVista agent processes them. The collage on the left shows varied scenes from street photos, storefronts, malls, and panoramas, which highlights that the benchmark spans many countries and viewpoints. On the right, the agentic pipeline diagram shows a user query flowing into the policy model, which repeatedly chooses actions and receives observations. Those actions correspond to two tools, image zoom in and web search, so the model can inspect fine visual details and cross-check them with online information before giving a final location. Table 1 makes the case that GeoBench fills a gap among geolocation datasets. The table lists prior benchmarks by year and marks whether they offer global coverage, reasonable localizability, high resolution, data variety, and nuanced evaluation based on exact coordinates. Only GeoBench checks all 5 boxes, which means it is both broadly global and carefully labeled for fine-grained, distance-based scoring. Figure 4 explains how GeoBench scores model answers and where the images come from worldwide. The left panel shows a 2-stage evaluation pipeline that first checks whether the text answer names the correct country, province, and city, then converts the answer into coordinates and measures the Haversine distance, which is the Great Circle distance on Earth. The right sunburst chart visualizes dataset coverage across continents, countries, and cities, so it makes clear that the benchmark spans diverse global locations. Table 2 shows that GeoVista, the 7 billion parameter open-source model, clearly dominates other open-source systems across all GeoBench accuracy metrics. The table reports how often each model gets the country, province, and city correct, plus separate city accuracy for panoramas, photos, and satellite images. GeoVista leads every open-source row and often comes close to the best closed-source scores, which is impressive given its much smaller size. Alright, 2 takeaways stand out. GeoVista shows that a compact 7 billion parameter agent, when armed with zoom and web search tools, plus careful supervised and reinforcement learning, can rival much larger closed systems, and GeoBench offers a realistic testbed for future agentic vision research. That is it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.